You recognize this substance, right? Every living creature on the earth uses it every day to just stay alive. It is one of the most common, most abundant substances in the entire universe. As we use it every day for not just drinking but also for many other purposes, therefore we must have to know some of its uncommon, unusual, and apparently weird properties. Water has a lot of weird and uncommon properties, such as high surface tension, briefly described in this topic of chemistry book. Generally, at rest, the water surface stretches a little bit. This is because of those attractive intermolecular forces that are present between the molecules of the water. This steel paperclip, which has higher density than water, can float on its surface due to this strange property, which is high surface tension. Same goes with this razor blade. An insect called water strider uses this weird property of water plus its long hydrophobic legs to stay on top of the surface of water. Therefore, it can walk on it without submerging in it. The second weird and uncommon property of water is that it is a universal solvent. This property is described by this topic of chemistry book. Water is a universal solvent because it is capable of dissolving more substances than any other liquid. All the chemical reactions in our body, aka the metabolism of the body, takes place in the presence of water. And the third weird and uncommon property of water is its ability to absorb a ridiculously large amount of energy, which is called its heat capacity. The heat capacity is described by this topic of 9th grade physics book. As explained in this reference book, that it takes an enormous amount of energy to raise the temperature of water by just 1 degree, which is its heat capacity. It takes so much amount of energy to heat the water and therefore evaporate it. It means that water is pretty good at removing heat from a fiery kind of hot kind of stuff. From now on in this video, I'll perform some amazing demonstrations which will present how good the water is in removing heat from fire, and therefore elaborates this idea of heat capacity, the very large heat capacity of water, and these demonstrations can help visualizing this amazing property of water. But before that, let us clear one thing in our mind, which is that the flame needs a really high temperature to sustain itself. If we are not providing this condition, if we are not providing that particularly high temperature so that the flame can sustain itself, the flame will extinguish by itself. And we will use water to do exactly this, to remove heat from the fire. So let's start. What I have here in this part of the table is the stuff for a demonstration which is called the paper will not catch fire. For that, what I have here is an alcohol, which is isopropyl alcohol to be precise, which is a really flammable liquid. And on the other hand, I have water, which is used to kind of extinguish a flame, which will not burn in any case. So, which is actually used to extinguish a flame, to remove heat from flame. So, what happens if we mix them together? So, this is a theory, and if we mix them both together in a equal kind of proportions, what happens is that alcohol will burn, and at the same time water will remove heat from that burning alcohol, and we'll see what will happen. So now I'll prepare the solution in front of you. I'll pour about 100 milliliters of alcohol in this glass bucket. About 100 milliliters, this. And I'll pour about the same amount of water in it. This. Now, what in this bucket is actually a mixture of a flammable liquid and a liquid which is known to be a fire extinguisher. So I can smell the alcohol here. So I'll mix them. The alcohol will burn with a blue flame, and what I have here is some table salt, which is NaCl, sodium chloride. The sodium in this sodium chloride will make the flame visible to us, because alcohol burns cleanly. It burns with a blue flame, and which is not visible to the eye. So I'll make it visible by adding some sodium chloride in it. So sodium will help us to see the flame. Actually, it turns the fire yellow, which is more visible to the eye. Let me mix it properly. So what I have now is a mixture of alcohol, water, and some salt in it. So now I have made this mixture of alcohol and water, 50% alcohol, 50% water, and some salt in it. And what I'll do is I'll soak this piece of paper. Now, paper is a really flammable stuff, you know that. If I burn this paper in the normal conditions in the open air, this will catch fire like this. So you know that in the normal conditions like this in the open air, the paper will catch fire. But what if I change the condition a little bit? So what I'll do is I'll take this piece of paper, this is the same pretty much identical piece of paper, and I will soak it in this mixture of water and alcohol. Now we can test the theory. So here we go. This is nice. The paper is intact. It feels wet, but it is intact. This is okay. There's no sign of burning. This is a great demonstration to teach how heat capacity works, how water can absorb, can intake so much amount of heat and prevent this flammable piece of paper. This is quite nice. This is out of intuition. This is enchantment, and this is magic. For the next demonstration, I will fill this paper cup with water. Water goes like this in it, and I'll burn the brim of this paper cup to really just see the effect. Certainly, when the flame will touch the surface of water, it will extinguishes by itself. This is theory, but let me check. It is burning really nicely, and you can clearly distinguish the area in which the water is present and the area without the water. This is a really nice demonstration to teach students how water removes heat from a burning flame. For the next demonstration regarding heat capacity, I have here two bowls or two trays filled with water. In the first tray, I'll make a soap solution, and I'll fill those soap bubbles, the bubbles formed as a result of that solution, with propane, with a flammable gas. And I'll see the effect of it. So let's see. So I'm pouring some soap in it. There goes the soap. There's a liquid soap, liquid dishwashing soap, and some glycerin. Glycerin is used to really make the bubbles strong. So there goes the glycerin. Small amount of it can do the work. So there goes the glycerin, and I'll mix it. So I have made this soap solution, and now what I will do is I will make bubbles of a flammable gas, the propane gas, and I will scoop up those bubbles and light them on fire. I'll make my hand wet by putting my hand in this bowl, and I'll scoop up some of the bubbles and I'll light them on fire. There it is. Gas is coming from this hose, and I'm making these bubbles of flammable gas. This is propane gas. I put my hand in water and therefore making it wet. I scoop up some bubbles from here and light them. I feel a burst of heat on my hand, and no burn at all. Water protected my hand from burning. It's that particular property, its amazing property to absorb an enormous amount of energy is protecting me from catching fire. I'll do it one more time. There is the gas is coming from that hose. I'm making those bubbles of flammable gas. Soak my hand in water and scoop up some of the bubbles like this. There. This is a pretty amazing way to teach the students how heat capacity works, how water is able to absorb a ginormous amount of energy, and therefore its applications in the real industry and in the real life applications of this idea of heat capacity. Now, the last demonstration regarding this topic of heat capacity involves some more fun, some more enchantment. So, what I have here is a balloon filled with air, filled with normal air from my lungs. I inflated it previously, and what I'll do now is I will light it on fire and see the consequence. So there it is. It will pop, obviously. Now, what I can do so that the balloon will not pop. The idea is to use water. I fill another balloon with water and see the effect so that water can absorb heat and therefore prevent it from popping. So there we go. What I will do now is I will fill this balloon with water. I'm filling this syringe with about 30 milliliters of water, and I put that water in this balloon like this. So there we go. 30 milliliters of water in this balloon, and I now inflate it. There we go. There is a little bit of water in this balloon, and let us test the theory. The water should prevent this balloon from popping. There is a little bit of water. You can check. It is sloshing back and forth. So let me do the honor. So I figured out that the balloon popped because its material was not strong enough to withstand that initial burst of energy. So what I have now is a balloon, is a pretty thick balloon. The balloon with the pretty thick latex. The rubber is quite strong, and it is really hard to, you know, inflate this balloon. So what I'll do is I will fill it with the same amount of water, 30 ml water, and here it says water goes inside the balloon, and now I will inflate it. I'll now apply heat to it from the bottom. Definitely the water is keeping it from bursting, taking all that heat energy, removing all that heat energy from this flame. Clearly this experiment works. No effect at all. The balloon should definitely pop, but the water is keeping it from popping. If you do this demonstration by yourself, make sure that you use a strong balloon, the balloon with a thicker latex. So what have we learned from all of this is that the water is pretty amazing stuff. It has, a lot of cool properties, which are pretty enchanting to investigate. The beauty inside the water structure, inside its properties, is ginormous. And performing these demonstrations inside a classroom will engage students with science more and more, and they can perform in the real practical world more amazingly, more better. So this was the demonstration lecture regarding heat capacity. I hope you enjoyed it, and I thank you for listening.